In this video, we will review antiderivatives. Let me start with the definition. We have that a function capital F of t is an antiderivative. Antiderivative of little f of t if f prime of t is f of t. Then when we want to compute the antiderivative of a function little f of t, we need to compute a function capital F of t with the property that f prime of t is equal to little f of t. We will write the antiderivative of little f of t dt is equal to capital F of t. But we notice that if we have an antiderivative and we add 5, then the derivative of 5 is 0, then this function plus 5 is also an antiderivative. Then sometimes we write plus c, just to make sure that when you add a constant, you still get an antiderivative, but we're going to omit that. We're going to say, okay, we know that if we add a constant, we get an antiderivative, and we just write one of them. If we see the list of derivatives, we can easily deduce the following things, that the antiderivative of t to the n dt is equal to t to the n plus 1 over n plus 1, and this is as long as n is different from -1, because we are not allowed to divide by 1. Notice that even if I use a t, the t is irrelevant. I can say that the antiderivative of u to the n du is just u to the n plus 1 over n plus 1, or I can use like a v to the n plus 1, sorry, the antiderivative of v dv is equal to the b to the n plus 1 over n plus 1. My point is that it doesn't matter if we use a t, a u, or a v. It's the same. Let's continue using this. The case n equal -1 is the antiderivative of 1 over t dt is natural log of absolute value of t, and the antiderivative of cosine of t dt is sine of t. The antiderivative of sine of t dt is negative cosine of t, and we can check the derivative of negative cosine of t is sine of t. The antiderivative of e to the t dt is e to the t, and the last one that we saw, the antiderivative of 1 plus t squared dt is arc tangent of t. Let's just see this list, and we have that the antiderivative of a sum of two functions is just the sum of the antiderivatives. This is easy. The antiderivative of a constant times a function is just the constant times the antiderivative of the function, but we don't have like a product rule. There is no like specific way to this. The closest we can get is something that is called integration by parts, but there is no formula for a product. And another one that is going to be important is called substitution. Then substitution. We have substitution, and the other one is integration by parts. And essentially, substitution is a direct consequence of the chain rule. Integration by parts is a direct consequence of the product rule. And instead of giving the formula, let me do some examples for substitution. Let's suppose that we have an integral. Let's start with an easy one. 1 over 3 plus 2t dt. we notice that this integral is not like those that we know how to solve. But then substitution says, if you can do a substitution, in this case, if you can make u equal to something, in this case I'm going to make u equal 3 plus 2t. Remember, substitution was something similar. We did a substitution. And if you can replace, if you can change this integral so that it looks like something, the t disappears and the dt disappears. But how do you change the t and the u? You can change here 1 over u, but how do you change the t? This is the rule. You take the derivative, and then you get 2, right? But then you pretend that you can split this like this, 2 times dt. Then what is your dt? dt is du over 2. Then here, this is 1 over u, and dt is du over 2. Now I have accomplished what I wanted to do. The t disappear and the dt converted into the du, and the t's are gone. Only an expression of u. Then substitution says if you accomplish that, then you can just integrate with respect to u, and that's your answer. In this case, we have 1/2 the antiderivative of 1 over u du, and this is 1/2 natural log of absolute value of u, and then the answer is when you replace back into this 1/2 natural log of 3 plus 2t. That's substitution. Let me do another example. We're doing example of substitution. And let's suppose that we have the antiderivative of 3t to the 5 plus 4, let's say 3t to the 6 plus 4 to the 1/2 times t to the 5 dt. Notice that this is very far from being one of these lists on the left. But then substitution says if we can find a function, in this case the function is 3t to the 6 plus 4, in such a way that every time the t's are going to disappear and you're going to end up something that has only u and du. And what is the rule? Here is du over dt is 18t to the 5th. From here we get that du is 18t to the 5th dt. Then let's change this. The idea is to make disappear the dt and all the t's. What do we get here? The u, this is u to the 1/2, and look here, we have t to the 5th dt is here. This is du over 18. That means that this can be written as 1 over 18, the integral of u to the 1/2 du. The mission is to make this one looks like one of these formulas that we have here, and this one looks like this one with u equal to 1/2. Then the property says this is 1 over 18 times u to the 1n plus 1 will be 3/2 divided by 3/2. And then this is just 9 times 3 is 27, 1 over 27 u, but then you can replace u to this expression, 3t to the 6 plus 4 to the 3/2. Then this is the antiderivative, or one antiderivative of that. Okay, when you are doing substitution, just make sure that you accomplish one of the very well-known antiderivatives. Let me just say that a common mistake that people do is like the antiderivative of 1 over 1 plus t squared dt. Sometimes people say this is 1 plus t squared. This is wrong, right? You can, in this case, this antiderivative actually is in this table. is arctangent of t. And you can see that the substitution u equal 1 plus t squared is not going to help here. Let's do some examples of let's do some examples of integration by parts. Integration by parts, let's do an example. This is the classical example, e to the 2t dt. It says that if you have an integral and you can make this integral look like the antiderivative of u times dv, then if you accomplish this, then this antiderivative can be changed into the product u times v. Notice that here you are not doing any antiderivatives. Minus, here you have to do an antiderivative of b du. And this is essentially the product rule. In this case, let's do u, for this particular example, let's make u equal t, and then dv equal to e to the 2t dt. Notice that making dv equal to e to the 2t dt, it means that I'm doing dv dt equal e to the 2t. The derivative of v with respect to t is e to the 2t. Then what is v? v would be the antiderivative of e to the 2t. And this antiderivative, if we do a substitution, u equal to 2t, we get that this is 1/2 e to the 2t. Notice that if v is 1/2 of e to the 2t, the derivative is e to the 2t. Then with this substitution, we have that du is equal to du over dt is equal to 1, and v is e to the 2t. Then the formula says this is equal to u times v, this is t, sorry, v is not e to the 2t, is e to the 2t divided by 2. Then it says this is t times v minus the antiderivative of v, which is e to the 2t over 2 times du, but du is just dt. And then this antiderivative is t e to the 2t over 2, and the antiderivative of e to the 2t, we already did it, is 1/2 of e to the 2t, but there is another half here, that is minus 1/4 e to the 2t. Then this is the antiderivative of this function. I think this is all that I wanted to show you right now, and then I'll stop here.